Hello everybody, this is our first lesson of the Advanced EM. We will use the book called Introduction to Electrodynamics by David Griffiths. This is a very familiar and famous book used in most of the universities, just like in Chinese University of Hong Kong and UST. We will skip the first chapter, which is just some vector calculus, and you can read by your own. We'll start first in the chapter 2, electrostatics. The first concept of electrostatics is that you should know that what does electrostatics means. Statics means stationary, so we will consider all charges is stationary in this chapter. If the charge is moving, is not in this chapter. Charge move, it will cause a current. We first look how to calculate an electric field. We have many source charges in here in a space in different positions, and we have a test charge. A test charge, what criteria should be a test charge be? Is the charge is small and its size is small. We have talked about it in other courses. We just consider one charge, one source charge first, and the force on the test charge by the source charge is given by the Coulomb's law. 1/4 pi epsilon naught small q big Q over tau square and tau hat. This is our inverse square law. Is proportional to the distance proportional to the inverse square distance, and the tau hat means the direction. You can see that in the figure 2.2. And epsilon naught is a defined constant. That means there is no error. It's given it's defined to be exponent 5 times 10 to the power negative 12, and its unit is Coulomb square over Newton over meter square. And what is tau? Tau is just the displacement or separation between two charges from the source charge to the point to the test charge. And in general, it's r minus r pi. You will see that in the next figure. This figure 2.3. We have just considered one test charge. What would happen if there are many source charges? By experience, we found that electric field obeys the law. Which law? The principle of superposition. So we can just add them up one by one as we consider that other charge. When we consider, for example, when we consider Q1, we will ignore other test charge, other source charges, and then sum them up. We calculate the final force, just the net force, and it's given by these equations. First field. We consider we have just considered a point charge. How about continuous charge distributions? By superpositions, we have summation. Just change it into our integration. We have this equation 2.5. and then we will consider other cases. a line charge, a surface charge, and volume charge. And lambda is the line charge density, sigma is the surface charge density, and the rho is the volume charge density. It's just given by the charge over length or area of the volume. And then we can just replace the Q, the infinitesimal charge, into lambda dl pi, or sigma dA pi, or rho d tau pi. We have looked. That's why we have to change into the surface charge or volume charge before. Just this equation is very trivial. Yeah. And the next lesson we will talk about the divergence and curl of the electrostatic fields. Thank you.